Hello and welcome back to another episode of Math with Zone. Today we are going to be doing a lot about functions. We're going to be determining the domain and range, whether it's a function, whether it's one-to-one, or linear or nonlinear in every given way. So the first few are with it graphed for you. We are going to determine first if it is a function using the vertical line test, and then if it is one-to-one using the horizontal line test. Okay? So in order to pass the vertical line test, you have to be able to have a vertical line be drawn somewhere and everywhere on your paper, and if it only crosses through one time the entire time, then it would be a function. So see how here, when I have this vertical line, which is really a paper clip, it only ever crossed one time at a moment, versus on this second graph, where I have two intersection points on this singular vertical line, this would not be a function because it failed a vertical line test. Whereas over here, this would be a function, so we say yes function over here. All right? And on the third one, you can kind of tell this is a line. Lines are a function. It only ever passed it one time, so yes function here. Yes function. Yes, it is a function. Now we have the horizontal line test, which is the exact same idea. If it crosses through more than one time, like it does here and here, or even here and here, then this would be not one-to-one functions. Whereas here, even on the second problem, even though it failed the vertical line test, it actually passes the horizontal line test, so this would be a, yes, one-to-one function. And a line, of course, is going to be one-to-one as well. So this would be yes for one-to-one. All right, so that's how you deal with them graphically. Graphically sometimes is the easiest, but there are other versions of it. We can have a table or an equation. So given a tabular version of it, you should be looking for if the x values repeat or if the y values repeat. If the x values repeat, then it would be considered not necessarily a one-to-one function. If the y values repeat, then it would be not a regular function. So here, let's start with the y's. See how the y values repeat? 3 and 3. If the y values are both 3 at a specific point, then it would be not one-to-one because see how here, this y value and that y value are both at like positive 3. So it could still be a function, but it would not be one-to-one if the y values repeat. So this would be a no. Do the x values repeat? No. X values are 2, 4, -1, and 5. So this would be considered a function. So it is a function if x values repeat. It is not a function if the y values repeat. It is not one-to-one. And I might have mixed up the wording. That's why I decided to write it down. All right. Here we have a -1 and a -1 for x. So that means that it is not a function. And none of the y values repeat. So it is okay there. We will later on do linear, nonlinear. Here, do the y values repeat or the x values repeat? No, everything is identical. 2, 2, 3, 3, 4, 4, 5, 5, but none of the x values and none of the y values repeat, so both of these are okay. It is a function, and it is one-to-one. To determine if it is linear or nonlinear, you have options for graphing it to see what's going on, and I think that would be the quickest and easiest way. It doesn't have to be a perfect graph. To kind of get the idea, 2, 2 is right about here. 4, 3 is a little bit lower. -1 and 3 is right about there. No, 4, 3 is a little bit higher. And -1, 3 is a little bit lower. This looks like it is going to be something that kind of goes up and then down. And it's not doing a whole lot there, but that to me indicates that it is nonlinear. If it goes up and then back down and then back up or anything like that, you know it's not going to be a true line. All right, here we have 3, 4, 3, 4, somewhere around here. -1, comma 7, somewhere up there. 8. 8, we're back up top. Okay, so if we're back up top, that means that there's some sort of change in direction. That means that it is nonlinear again. And here, the last problem, we got 2, comma 2. -3, comma -3, 4, comma 4, -5, comma -5. This is actually just a line. I missed the dots, but it's a line, so this is linear. All of those dots line up, and I think it actually has a slope of 1 over 1. I think it's the slope of 1 over 1 and might even go through the origin. All right. So, equation-wise, this is where we're going to kind of have an issue with determining whether or not equation-wise it is, in fact, a function or one-to-one. There are ways to determine it, okay? And there are some tricks that you could learn, but it's not always a guarantee with the tips and tricks. Some of them also can be graphed if you have a graphing calculator, but hopefully you can understand this. If it is a y equals a number and then an x, you are 100% every single time going to have a line. That is y equals mx plus b. So that is a line. If it is a line, it is a function. It is one-to-one. It is the problems that have you squaring the x, or dividing by x, or squaring the y, or multiplying or dividing by x. Those are the ones that are going to have an issue with being a function, linear, nonlinear, and all of that stuff. So if it's not y equals mx plus b, it is a nonlinear. Is number 5 y equals mx plus b? Almost. You're not multiplying by the x, you're dividing by the x. And dividing by x actually makes the problem very, very funky and a nonlinear as well. Okay, with that in mind, we can still maybe determine if it is in fact a function or not. So looking at number 6, I'm going to start there. Anytime you have an x squared, whether there's parentheses or anything else, that is going to form a parabola. And this particular parabola will go to the right by 2 and up by 1. So it's going to look like that. So that will pass the vertical line test, but fail the horizontal one. So it is a function, but it is not one-to-one. So that tells you something. Anytime you have an x squared, it is not going to be one-to-one. If you had a y squared, would be a not a function. Okay? So x squared, not one-to-one. Y squared, not a function. Now dividing by x, that's a whole different ballgame. And to prove how crazy this graph actually is, I'm going to graph it for you. Here we go. Let's graph it. We got 3 divided by x. I'm going to put it in parentheses just because I forgot to hit. Oh, well, I'm going to have to. Let's just 3 over x plus 1. This graph will look crazy. All right? But even though it is as crazy as it is, it still passes everything. We can draw a horizontal line. It only passed through once, only passed through once, only passed through once. It looks like it might cross through twice here, but it actually doesn't. It's a blank in the graph. Same thing vertically. So it's still a function. It's still one-to-one, but it has this big gap in the middle because you can't divide by 0. All right? Here we go. Next phase of the lesson is going to go probably, hopefully, a little quicker. Discrete, continuous, or discontinuous. So a discrete is when you are counting, all right? Or if you can get an exact value for something. Continuous could be any given increment in between. So the number of marbles in a bag, you can really have 1 marble, you can have 5 marbles. You can't have a negative amount of marbles in the bag. What about the weight of an elephant? Well, the weight of the elephant can be any given weight from like 0 to, I don't know, however heavy elephants go. So this would be what I would consider continuous. Because we don't have an upper threshold. But you could also argue that this is discontinuous because the weight of an elephant, could, I wish I could spell, discontinuous, that's what I'm attempting to spell, could be capped like it is here on part C. The price per pound of coffee up to 10 pounds. This one, there are 2 ways to view it. If you view The up to 10 pounds, the weight is discontinuous. Where it is continuous, you can have 9.1 pounds, you can have 9.11 pounds, you could have 9.111 pounds, 9.12 pounds, 9.123 pounds. Any of those numbers are fine. What about the price? Well, the price is dictated by the currency that you're dealing with. And the currency that we're dealing with is a counting thing. You can have a 10 cents, you could have 11 cents, you could have 12 cents. You can't really have 12.2 cents. All right? So this one, I would argue, is discrete. It is not fully continuous. It is discrete. The weight is discontinuous, but the actual price per pound is discrete. The number of marbles in a bag. Well, that one is the definition of discrete. When you are counting, that is discrete. When it is smooth, that is continuous. If it is smooth but jumpy, that is called discontinuous. So if you're like, yeah, we can be any number from here to here, from 0 to 8, but then we can't be 8 to 9, and then we're any number from 9 to infinity. That would be like discontinuous. Okay? Let's do some domain and range practice. And then we'll be moving on for the day. So, domain and range. You know what? I'm gonna do a two-parter for this one because I feel like this is a good stopping point. And then we can do domain and range and putting it all together. All right? So stay tuned. I will see y'all in the next one. Bye.